Object-oriented programming is a programming paradigm that is based on the concept of objects. But what exactly is an object? Well, think of an object as a real-world object. It has properties like color, shape, size, and behaviors like moving, making noise, and so on. And that's exactly what an object in OOP is, a self-contained entity that consists of both data and behavior. Now, you might be thinking, why use objects in programming when we can just use data and behavior separately? And the answer is simple. Using objects in OOP makes it easier to organize and manage your code, making it more maintainable and scalable in the long run. Just imagine if you had to manage all your code as separate data and behavior, it would be a mess. Let's take an example. Let's say you have to write code for a car. A car has properties like make, model, year, and color. It also has behaviors such as starting the engine, accelerating, and stopping. In OOP, we would create an object for a car, and we would represent these properties and behaviors as variables and methods in our code. Now, let's talk about one of the key concepts in OOP: encapsulation. Encapsulation means that the data and behavior of an object are both hidden from the outside world. This protects the data from being accidentally or intentionally changed, and it makes it easier to make changes to the object's behavior without affecting other parts of the code. Imagine if you had a car that you could see all its inner workings, like the engine and transmission. Now, imagine if someone went and started playing with the engine, causing it to break. That's exactly what can happen if your code isn't encapsulated. But with encapsulation, you can protect your code from being damaged by others. Next up, we have inheritance. Inheritance is like having a family tree, but for objects in OOP. It allows us to create a new object that is based on an existing object. The new object will have all of the properties and behaviors of the existing object, and we can add or override properties and behaviors as needed. This makes it easier to reuse code and avoid duplication. For example, let's say you have a car object, and you want to create a sports car object. The sports car object would inherit all the properties and behaviors of the car object, and you could add or override properties and behaviors, such as the top speed. This way, you don't have to write all the code again, you can just inherit it and make the necessary changes. Last but not least, we have polymorphism. Polymorphism is like a magician. It allows us to treat different objects as if they are the same type of object. For example, you could have a list of cars, and each car could be a different make and model, but you could still call the same method on each car, such as start the engine, and it would work for each car in the list. In conclusion, object-oriented programming is a powerful and widely used programming paradigm that makes it easier to organize and manage your code, making it more maintainable and scalable in the long run. Encapsulation, inheritance, and polymorphism are the key concepts in OOP that make it so powerful.